Hey, what's up? It's Sam from HiViz LED Lighting, FireTech lights. So today I'm going to do a little demo on compartment lights, and we get asked all the time, what makes a FireTech compartment light different or worth the money when comparing to the other types of compartment lights on the industry? So this is one of ours that we've taken apart. You can see the inside of it, and I've actually got the end cap off. So the big two differences are, one, that this thing's all aluminum, and so the fixture itself is more durable than most compartment lights, but it gets into a lot deeper where we can dissipate heat a lot better. So the aluminum's great for, of course, the structural rigidity, but of course the thermal management. So let me just show you a couple of styles. So there's basically three styles. So if you look at style 1, this is kind of your cheaper LED compartment light. We'll call this style STYLE 1. It's going to be a round poly tube, and so it just goes on the inside and it's clipped to the side of the body. And that poly tube has a circuit board that sits inside just like this, and that circuit board has LEDs on it, and it's usually a fiberglass circuit board. And that circuit board runs the length of the compartment. So if you look at it from a side view, this is the side view, and it's got, we'll put the circuit board this way, going inside, and then it's clipped onto the body with a few plastic clips. The wiring comes in the top side, and these circuit boards clip together at the inside. There's pins, so they get pushed inside, and when those pins get pushed together, those boards lock in place, and then they sit inside that poly tube. So that's a low cost way to do it, and it's fine because these things are fairly bright. But the problem with this is that the LEDs themselves dissipate heat off the back of the chip. So if they're dissipating heat off the back of the chip and they're just on a fiberglass circuit board, there's nowhere for that heat to go. And then because that circuit board is inside of a plastic tube, it vibrates back and forth as a truck goes down the road. So the fiberglass itself is prone to failure, and then the junction where the pins interact is prone to failure. And then of course the whole thing being plastic just takes one good whack from a K12 and the thing is trash. So the other style, we'll do style 2. Style 2 is a little bit better, and this is the style where you have an aluminum extrusion, but the circuit board is cut and built in a whole long batch, and then it's cut in sections and put inside. And what happens is these circuit boards are totally encapsulated in an epoxy bath. And that epoxy encapsulation keeps them from getting problems with water. It keeps them waterproof, but the problem with that is that the epoxy ends up an insulator, and then of course you have a temperature problem. So let me just draw this out. So when you look at this type of extrusion, so we've got a little pocket, and then I'm going to come back up, and we've got the rest of that pocket, and this might go up. So this type of extrusion, the circuit board that sits in here, it slides in, and let me just draw this circuit board. The board sits in the middle of this epoxy encapsulation. It's got LEDs on the top. So what happens here is the whole piece, it's sort of similar to where it's extruded, but the circuit board can't get rid of the heat because this whole area around, totally encapsulating around where the chips are, is that epoxy. And epoxy is like a plastic, and just like anything, we know that plastic is an insulator. So this style is a lot better than this style because it's more durable, it's more waterproof, and it gives you a little more light output because it does have some strength to it. But style 3 is the FireTech style, and we take the circuit board and we build this thing more like we do one of our scene lights, like our FireTech brow light. Let me just draw this out and then I'll point to it on the fixture. So FireTech. So the way that our fixture goes, this is the housing right here. So if you look at it down the side, it's shaped like a U. Sitting directly on the housing is our circuit board. So on top of the circuit board, of course, is the LEDs. But the heat from these LEDs pushes back into the housing, and this aluminum housing has ribs on it, and those ribs, all these ribs that are in here, act like a heat sink. So this whole big aluminum housing, because the circuit board is bonded to the aluminum housing, allows way better thermal dissipation, and the key to the success of an LED over the life of an apparatus is the ability to manage the thermal load, the ability to shed heat, because if they get too hot, then they break down and they just fail. So the problem is when you bond these together, now you've got a big void space, you don't want water getting inside. So what we do is we epoxy encapsulate once the fixture has been manufactured up to the top half of the LEDs. So the board is bonded to the housing, and then we epoxy the top half and keep the open face, the phosphorus face of the LED out to the atmosphere. But if you look here, you see how that whole area would be covered in the epoxy potting. So that keeps it totally waterproof. But then we also add a little ridge on the top side, and then we have a gasket right here. So if you look at this piece, this is actually that gasket. I can pull a piece of it out. You see that gasket right there? So that gasketed material goes on the top side, and then we add a lens. And that lens goes on top of the gasket, and when you pop it in place, and I can even show you here, when you pop it in place, it creates a waterproof seal. And so we not only have a waterproof design where the circuit board is epoxy encapsulated so you don't get water on the LEDs. We also have a lens on top of it that is also waterproof, so the whole housing is designed to be used in higher vibration environments because we don't have to worry about these style 1 type fixtures where the circuit board rattles around inside of a piece of plastic tubing. It's designed for high temperature environments, so like a closed compartment or like a compartment, even the underside of a fire truck where you've got dirt and junk and trash all over these things. We're able to dissipate the heat because of these fins and the aluminum housing. And we've also got the durability of having all aluminum mounting points. So when you look at this lens gets installed on the top side, and then we have an aluminum end cap. And this light here has actually been under my truck for a couple of years, and we just pulled it back for some testing. But this all aluminum end cap bolts into this extruded housing. And when it's bolted on, there's a little rubber gasket that goes over here. Oops, here it is. And when it's bolted on, it allows for a mechanical fastening of the housing all the way to the fire truck body. So the likelihood of this thing getting knocked off the truck is very low because of this aluminum end cap and aluminum housing holding an aluminum circuit board all on board the compartment of the fire truck. You can bang this thing as hard as you want. The K12 is not going to rip this thing off the side of the truck body because it's actually mechanically attached using aluminum and screws. So anyway, there's a lot of different types of compartment lights on the market. I can't say that anybody builds a bad compartment light, but when it comes to a FireTech compartment light, we started with the design requirement that this thing had to last 25 years in service, under a fire truck, on a fire truck, anywhere you put it. And this is the way we did it. So anyway, check us out online at HiVizLEDs.com, and we'll look forward to serving you soon. Have a good day.